Hi kids, in this video we are going to solve sums from Concise Mathematics, exercise 14C, rectilinear figures from class 9. Look at the first sum. I've already explained the property. You can go through it, okay? E is the midpoint of side AB and F is the midpoint of side DC of a parallelogram ABCD. Prove that AEFD is a parallelogram. Very easy. First, draw the diagram. So suppose this is my A, B, C, D. What is given to us? It's always better if you write what is given and what is required to prove. Given is E is the midpoint of AB, F is the midpoint of DC. And what is required to prove? RTP, that AEFD is a parallelogram. Very easy. Look over here. Suppose we have E over here, we have F over here. Just join this. We need to prove that AEFD is a parallelogram. Now this is parallel to this, we know, and AD is parallel to BC. So if we can show that AE and DF are equal, then our work is done. Because in a quadrilateral, if one of the opposite pair of sides are equal and parallel, then the quadrilateral is a parallelogram. Now look carefully. AB is equal to CD, opposite sides of a parallelogram, no doubt in that. Okay, E is the midpoint of AB, therefore AE is equal to EB. Why? Because E is the midpoint, isn't it? Similarly, F is the midpoint, so I can say DF is equal to FC. Why? F is the midpoint. Now since AB and DC are equal and E and F are the midpoint, we can say by these three that AE is equal to EB and this will be equal to DF will be equal to FC. Suppose AB is 10. So this is 5, this is 5. CD is also 10. So this is 5, this is 5. Ultimately, AE, EB, FC and DF are all equal in length. Am I clear? Now, in quadrilateral, just see, in quadrilateral, AEFD, we just got AE is equal to FD. See, AE equals to FD or DF is the same thing, and AE is also parallel to DF. Why? Because AB is parallel to DC, isn't it? So if AB is parallel to DC, it means the portion of AB, that is AE, will be parallel to the portion of CD, that is DF, which implies that AEFD is a parallelogram. Why? Because opposite sides are equal and parallel to each other. So it has to be a parallelogram. Clear? Now let us look at the next sum. Now look at sum number 2. Pretty easy. The diagonal BD of a parallelogram ABCD bisect angle B and angle D. Prove that ABCD is a rhombus. Look, first of all, we need to draw the diagram. So suppose this is your parallelogram A, B, C, D. So this is parallel to this side and AD is parallel to BC. Now they've given the sum that BD given. What is given to us? Given is BD bisects angle B and angle D. What is required to prove? That ABCD is a rhombus. Now that's pretty easy. When does a parallelogram changes to rhombus? If the adjacent sides are equal. So if you can prove that AB is equal to AD, your work is done. Okay. Now look carefully how I'll do that. Now in a parallelogram, the opposite angle are equal. See, angle B is equal to angle D. Suppose is equal to 2x. I've taken this entire angle as 2x. So this also becomes 2x because the opposite angles are equal. Opposite angles of a parallelogram, they are equal. We know that. Now BD is the bisector, which means angle ABD, look carefully, angle ABD will be equal to DBC, will be equal to x degree each. So this is x, this is x. Then only this entire thing becomes 2x. Similarly over here, angle BDA is equal to BDC. BDC is equal to x. So this is x and this is x. Am I clear or not? Now look carefully. This angle and this angle are x degree each. Look at triangle ABD. If I can prove that it's an isosceles triangle, our work is done. See, in triangle ABD, angle ABD is equal to angle ADB. ADB is equal to x, given, isn't it? So if the base angles are equal, look carefully. If these two angles are equal, then this side and this side will be equal in length, which simply implies, see, opposite to this angle, AD, and opposite to this angle, we have AB. So AB is equal to AD, which implies triangle ABD is an isosceles triangle. Even if you don't write that, that's okay. So we just got AD is equal to AB, which means adjacent side of the parallelogram ABCD are equal, which means, can I say AB is equal to AD and AB is equal to CD, we know, and AD is equal to CB, which means all the sides are equal, which implies ABCD is a rhombus. Done. Is it clear? Very easy. Just prove that AB is equal to AD by isosceles triangle property. Our work is done. Okay. Now let us look at the next sum. Now look at sum number 3. The given figure shows a parallelogram ABCD in which AE equals to EF equals to FC. This is given to us. Prove that DE is parallel to FB, DE is equal to FB, and DE BF, which means we'll join this. Am I clear? So this figure is a parallelogram. Okay. What is given to us? AE equals to EF equals to FC. What I'll do, I'll first draw the diagonal of ABCD. Okay. Now one thing we should know, that in a quadrilateral, if the diagonal bisect each other, then that quadrilateral is a parallelogram, which means DEBF. If you can show that EO equals to OF and DO equals to OB, then this quadrilateral changes to a parallelogram. Once this is proven, these two are the consequence of this only. So what I'll do, I'll first try to do this part, okay? The third part. Look carefully. AO, first of all, DO is equal to OB, okay? And AO equals to OC, because the diagonal bisect each other in a parallelogram. Now look carefully. AO is equal to OC. AO, can I write AE plus EO, and OC can I write OF plus FC. Now FC and AE are equal, which means EO equals to OF. Done. Now look at the quadrilateral DEBF. BD and EF are the diagonals, and clearly OD equals to OB and EO equals to OF. The diagonal bisect each other, which means quadrilateral DEBF is a parallelogram, isn't it? Because the diagonal bisect each other. Once it's a parallelogram, we know that the opposite sides are equal, which means DE will be equal to FB, and the opposite sides are parallel also, which means DE is parallel to FB. Why? Because of this, because DEBF is a parallelogram. Done. Very easy. Okay, first prove this part and then the two parts. Now let us look at the next sum. Now look at this sum. Pretty easy. In the given figure, ABCD is a parallelogram. AB is parallel to CD and equal, and AD is parallel to BC and equal, in which AP bisects angle A. So if angle A is supposed twice x, then this angle will be x, this will be x. No doubt in that, isn't it? Because AP bisects angle A. Similarly, BQ bisects angle B. So if I take the entire thing as 2y, this will be y, this will be y. Suppose angle B is 2y. So if we know that BQ bisects angle B. Is this clear or not? The entire angle is 2x. So this is x, x, this is 2y, y, y. Now we need to prove that AQ and BQ are equal in length. Pretty easy. PQ, we'll just join it, is equal to CD. PQ is equal to CD, and ABPQ is a parallelogram. Look carefully, first of all. Now, AD is parallel to BC. AD is parallel to BC. BQ is a transversal. So this angle and this angle has to be equal. Angle QBP will be equal to BQA. BQA, that's alternate angle. We have taken it as y, isn't it? Now look at triangle ABQ. In triangle ABQ, so this is y. Angle ABQ is equal to angle AQB is equal to y degree, which means triangle ABQ is an isosceles triangle. And if it's an isosceles triangle, we can say that AB is equal to AQ. No doubt in that. Okay. Now look carefully. So we just got that AB and AQ are equal in length. If we can show that AB and P are equal in length, our work is done. Look carefully. Suppose this is 1. In triangle I'm talking about ABP. Triangle ABP. Look over here. This is x. So this has to be x, isn't it? Because this is x. Angle APB is equal to angle PAQ. That's alternate angle. That is equal to x. Now look carefully. ABP. Angle BAP. This angle and this angle are equal. So it becomes an isosceles triangle. Angle PAB is equal to angle APB is equal to x degree, which means, can I write triangle ABP is an isosceles triangle, which implies, if you look, AB equals to BP. Suppose this is 2. So what I did, ABQ, I proved it's an isosceles triangle. So this side and this side are equal. ABP, I proved it's an isosceles triangle. So this and this side are equal. So comparing 1 and 2, look carefully. Comparing 1 and 2, we can say that AB equals to AQ equals to BP, which simply means that AQ equals to BP. Proved the first part. Done. Now PQ is equal to CD. That's very easy. Now look, ABPQ. In ABPQ, AQ is equal to BP and AQ is parallel to BP. So if opposite sides are equal and parallel, it's a parallelogram, which means can I write quadrilateral ABPQ is a parallelogram, isn't it? Because of one of the pair of opposite sides are equal as well as parallel, which simply means that AB is equal to QP. AB equals to QP. Now look, we know ABCD is a parallelogram. ABCD is a parallelogram. Okay, ABP, this is done. See, ABPQ is a parallelogram. The third part is done. We do the second part. ABCD is a parallelogram, which means AB is parallel to CD and AB is equal to CD. AB is equal to CD. So look at this number 3 and number 4. If you compare them, then AB is equal to QP is equal to CD, which means we can say that QP equals to CD, which means simply QP equals to CD. And this is what we were supposed to prove. Done? Clear? First we did this part, then this part, and then this part. Okay, remember, in a quadrilateral, if one of the opposite pairs are equal and parallel, then that quadrilateral is a parallelogram. Clear? Now let us look at the next sum. Now look at this sum, sum number 5. In the given figure, ABCD is a parallelogram. Prove that AB equals to twice BC. AB equals to twice BC. And they have given that DAE is equal to EAB, which means AE bisects angle A and EB bisects angle B, because EBC and EBA are equal. They've already given. Now, see, what we'll do, this is parallel to this. Okay. Now, these two angles are equal. So, if suppose this is X, these two angles are equal. Suppose this is Y, this is Y. Now, look carefully. Let angle DAE is equal to EAB is equal to X, and EBA is equal to EBC equals to Y, assumed. Now look at this angle EAB, which means this angle and this angle. They are interior alternate angle because DC is parallel to AB. So DC is parallel to AB simply means that EAB, angle EAB will be equal to DEA, will be equal to X degree each. Why? Alternate angle. Always give the reason, okay? So we got this angle as X degree, okay? Which means if you look at the triangle ADE, in triangle ADE, we got these two angles are equal. See, angle DAE is equal to angle DEA is equal to X degree, which means it's an isosceles triangle. So the side opposite to these two equal angle will be equal, which simply implies that triangle ADE is an isosceles triangle, which implies, see, opposite to this AD will be equal to opposite to this angle D. So we got AD equals to D. So this is equal to this. Now look carefully. Now over here we'll do the same thing. Okay, look at EBC. AB is parallel to CD or DC, whatever. Okay, then EBA, angle EBA is equal to this angle, isn't it? This angle and this angle will be equal. Alternate angle. EBA equals to CEB. CEB equals to Y. Why? alternate angle. So this is y degree. Now look at triangle ECB. In triangle ECB, EBC, angle EBC is equal to angle CEB. CEB, isn't it? Equals to y. These two angles are equal, which means again triangle, which implies simply triangle ECB is an isosceles triangle. And if it's a isosceles triangle, we know that EC will be equal to BC. Am I clear or not? Not just look. This is 1 and this is 2. So we just got, look what we got. We got AD equals to DE and AD equals to DE, and we got EC equals to BC. Now AD and BC are equal. AD is equal to BC. We know this. This was 1. This was 2. So from 1 and 2 we can get that DE is equal to EC, which means E is the midpoint. Now once E is the midpoint, see, DC will be DE plus EC, which will be twice of DE plus EC. I'll take as DE only, so twice of DE, and DE will be equal to AD, and AD is equal to BC. So this I can write as twice of, suppose, DE AD, and AD is equal to BC. So we got DC equals to twice BC, and DC and AB are equal, which means AB equals to twice BC. Proved. Just prove that E is the midpoint. Once that is done, then DC is equal to AB. So AB equals to DC, and DC is what? DE plus EC. Instead of DE, we can write BC. Instead of EC, we can write BC. Done. Now let us look at the next sum. Now look at sum number 6. Prove that bisectors of the opposite angles of a parallelogram is parallel. Pretty easy. First draw the diagram. What I'll do, I'll take a parallelogram. Suppose I name it A, B, C, D. This is parallel to this. This is parallel to this side. And AB equals to DC and AD equals to BC. We know that. They are saying prove that the bisector of opposite angles of a parallelogram is equal. Suppose A and C we choose. So bisector of A suppose is AM, and bisector of C suppose is CN. We need to prove that given is what? AM bisects angle A, okay, into 2 equal half. Just draw it properly, just wait. So this angle and this angle are equal, isn't it? And CN bisects angle C. This is given to us. This angle and this angle are equal. We need to prove that AM parallel to CN. Pretty easy. In a parallelogram, opposite angles are equal. So let angle A is equal to angle C equals to twice x. Suppose. Okay. Then this is 2x, this entire is 2x. Now AM bisects angle A, which means this will be x, this will be x. CN bisects angle C, so this will be x, this will be x, which implies angle DAM, look carefully, angle DAM is equal to MAN equals to x. Why? Because AM bisects angle A, given though. And similarly, we can say NCB is equal to NCM equals to x. Why? Because CN bisects angle C. I think till here there will be no doubt. Okay. Now look carefully. If this angle is x, this will be also x, isn't it? Interior alternate angle. Angle AMD, angle AMD is equal to angle MAN, angle MAN equals to x degree. Why? Alternate angle. Now look carefully. AM and CN. Okay. Angle AMD. Look carefully. AMD, if you look, is equal to NCM. Equals to NCM. That is equal to x. Now look carefully. If these two are parallel line, if these two are lines, suppose we don't know whether they are parallel or not, but if these two angles are equal, we come to the conclusion that this and this are parallel. Why? Because these two are corresponding. See, if they are parallel, these two are equal, corresponding, the converse. If these two are equal, then these two will be parallel. Similar, see, AMD, NCM. Suppose CD is a transversal, okay, which implies AM is parallel to NC by corresponding angle property. This is corresponding angle. If these two angles are equal, then we can say that it's a parallel line. Try to get it. If this is parallel to this, we say this angle and this angle are equal. So if these two angles are equal, then this and this line will be parallel to each other. So we have used that property. Similarly, see, this angle and this angle will be also equal because this is x, so this is x, so these two are also x. Corresponding angle, isn't it? So we can say that AM is parallel to NC by corresponding angle property. Done. Now let us look at the next sum. Now look at this sum, sum number 7. Prove that the bisector of the interior angles of a parallelogram form a rectangle. I've drawn the figure. See, ABCD is a parallelogram. AP bisects angle A. So suppose if I take angle A as 2x, so this will be x and this will be x, no doubt. Okay. Then I've taken CR, look carefully, CR bisects angle C. Okay. Now angle A equals to angle C, opposite angles of a parallelogram. This is equal to 2x, which means this will be x and this will be x. No doubt in that. I have taken DS as the bisector of angle D. DS bisects angle D. So if suppose this is angle D, I've taken as 2y suppose. So this will be y and this will be y. Isn't it? Then I've taken BQ bisects angle B, and angle B and angle D are equal, which is 2y. So this angle will be y and this angle will be y. Till here any doubt? I don't think so. We need to prove, required to prove IJKL is a rectangle. Look, how are you going to prove that? Now, if I can show that all the angles, interior angles of this quadrilateral are 90 degree, my work is done. It's a rectangle then, if all the angles are 90 degree. Now look carefully. Look, angle D plus angle C, angle D plus angle C is equal to 180. No doubt, they are supplementary. Isn't it? Because these two are, co-interior. Supplementary, co-interior are supplementary. The reason will be co-interior, better. Okay. These two angles add to give 180. Okay. So we can say that 2y plus 2x equals to 180, which means x plus y equals to 90. Now look at triangle DLC. Triangle DLC. Angle DLC plus angle LDC plus LCD equals to 180. Angle sum property, which means if you look carefully, DLC we don't know, okay, LDC is Y and LCD is X, and this is equal to 180. This we already know, 90. So DLC is 180 minus 90, that's 90 degree. So we got this angle as 90 degree. Now look, in triangle AJB, again, this angle which is angle AJB plus this angle which is X plus this angle which is Y is equal to 180. That's angle sum property. You can see AJB. Okay, now this is 90 degree. So angle AJB equals to 180 minus 90. That's 90 degree. So we got this as 90. Now look at third, triangle AID. Triangle AID. Angle AID plus, which means this angle, plus x plus y equals to 180. Why? Angle sum property, which means angle AID will be 180, and this is 90, x plus y is 90, so that's 180 minus 90, that's 90 degree. So if this is 90, this has to be 90. Vertically opposite angle, look carefully, angle DIA is equal to JIL, angle JIL equals to 90 degree. Why? Vertically opposite angle. So we got this as 90 degree. Now it's a quadrilateral. So 4 angle add to give 360. In quadrilateral IJKL, if you see 90 plus 90 plus 90, 90 plus 90 plus 90 plus JKL equals to 360. We know in a quadrilateral the sum of the angles is 360. So angle JKL equals to 360 minus 270, that's 90 degree. So we got this as 90. So in quadrilateral IJKL, since all the interior angles are 90 degree, it simply means that IJKL is a rectangle. Is it clear? Somebody can say it can be a square. Square is a type of rectangle only. Okay, this angle we can find like this also, x plus y plus this is 180, so this and this angle will be equal, vertically opposite angle. Okay, so that was the sum. The diagram was very important in this sum. If you can't draw the diagram properly, you won't be able to get this sum clearly. So in this video, keep it till here. In the next video, we'll look at the rest of the sum from Concise Mathematics. Okay, till then, take care.